So let's look at a pedigree. So a pedigree is something that's going to show our family history. There's a few things on a pedigree we need to look at. First, right here on the side, these are the generations. So we have 1, 2, 3 generations. Again, males are going to be squares, females are going to be circles, and them joined together like that means that they had a marriage of sorts. Okay, so when we start to see this here, we can see that they have offspring 1, 2, 3, 4, 5, 6 offspring. You notice that the numbers are numbered from left to right, even though they're not the necessarily offspring, but they're numbered in the order of which they appear. That's pretty darn common so that we can look at individual number 4 in generation 2. So it's just an easy way to see that. We can also see through this is that we have some people that are inflicted and some people that are not. So let's look at who has this. So if you have Huntington's disease, you are going to be shaded. And if you do not have Huntington's disease, you will not be. So the first question says, which members of the family above are afflicted with Huntington's disease? So it's pretty easy. So generation 1, person 1 has Huntington's disease. Generation 2, Roman numeral 2, person number 2, 3, and 7 all have Huntington's disease, and generation number 3, person number 3 has Huntington's disease. So now we've identified the individuals in the family member within the pedigree that has that. Number 2 asks, are there no carriers for Huntington? If there's no carriers for Huntington's disease, you are either you have it or you don't have it. With this in mind, Huntington's disease is caused by a dominant or recessive trait. So how do we figure that out? Well, we can look at it this way. Let's look at it as being a dominant trait. We don't know what this one is, but we know that she would have to be recessive. So in this case, that means everybody who doesn't have it would be recessive. And if that's the case, then dad has to be heterozygous because mom has it. Mom can only give one trait then. And therefore, the second trait would go to dad. Dad has a 50% chance of doing that. Well, that makes sense because these children here, nobody has it for that. So that would make sense that they're recessive. Because mom's a carrier, she could give this, but dad can only give that recessive trait. So every child has the same 50% chance. So if we were to work this out, could this be a dominant trait or a recessive trait? Well, in this case, we just went with dominant first, and it worked. So this would be a dominant trait. So how many children of individual from 1, so this guy right here, and 2 have this disease? Well, they have 1, 2, 3 children with that disease, and we're going to be a little bit more specific. 2 female and 1 male. The fact that they have both male and female children having this disease, it's fairly unlikely that it's going to be an X-linked disease. Okay? For question number 4, how many girls did generation 2, parent 1, and 2 have? Well, they have 2 girls. How many of them have Huntington's disease? 1. So of the 2 girls, 1 of them has Huntington's. Their son does not. In question number 5, so how is individual 3, generation 3, person 2, that's this person right here, and 4 related? So these guys right here. Well, if you look back, mom and dad of this one are brother sister. So they are, dun dun dun, they're first cousins. Okay? So how is person number 1 in generation 1, person number 2, this girl right here, and 5 of generation 3 related? Well, that's pretty easy. This would be, I have too much ink on here. Let's clear that up a little bit. So we're looking at this person and this person. Well, she's a mom, and she had number 4, and number 4, of generation 2 had number 5. So that would make that person her grandson. So grandmom and grandson. That's what that makes that. So that's an easy way to look at a pedigree for understanding what those things are. Let's do one more. So this pedigree to the right is showing it's passing on hitchhiker's thumb. Is this trait dominant or recessive? Okay, so let's look at some stuff because we have some crazy stuff going on in here because you're seeing something new right now. So this new thing, that one's new. That's a double line. So that is a marriage between closely related family members. Note, this should be generation 3. Sorry for the mistake there. This is generation 3. Person 1 and person 2 are related. They're cousins. They're first cousins. And so, therefore, they have probably closely related traits for that. So, if we start looking at this, so I'm going to say that because do we have anybody in generation 1, generation 2, generation 3 with us? Probably not. However, here's what we do know. If this would be a dominant trait, we'll just put this as a dominant. That means one of these people has to have it. Since they don't have it, and just 1 and 2 has it, we know that this is probably a recessive trait. So how do we know? Well, neither of their parents have this disorder. So that means they're not expressing it. So one of them would have to express it for it to be a dominant trait. But since it's not being expressed and being hidden, it's a recessive trait. So neither parent has the trait. So now it's asking us to look at generation 3, individual 1, this guy right here, and generation 3, individual 2. How are they related? Well, they're siblings. They have the same parents. So, or brother and sister you could put too. So number 9, name 2 individuals that have hitchhiker's thumb. Well, that's pretty easy. We're going to look at generation number 4, and we're going to look at individual 1 and 3. So in number 10, it says name 2 individuals that were carriers of hitchhiker's thumb. So we're going to look at generation 3, individual number 1, and number 2. This question is asking, is it possible for individuals in generation 5-2 to be a carrier? Why? The answer is yes. Both of these parents are going to be a carrier of this trait. So possibly this person could also, we know it has one dominant trait, but we don't know what the other one is. So they actually have a 50% chance of having that homozygous recessive trait or carrying that recessive allele. So they could actually pass that on to their offspring as well. And so we could do one more of these because there's something new in this one too. So this is fun with the shaded. The shading is something that they don't usually provide because we don't have a really extensive family tree. That shows that that person is a carrier. They're not expressing the trait, but they have the trait. So they've actually done the hard work for us. So this trait is showing color blindness. And so what are the only sexes that carries color blindness? So if we look at these, all these ones I just highlighted, they're all female. With that in mind, what is the non-Mendelian trait for color blindness? Well, it's not Mendelian. This is an X-linked recessive trait. So it would be X recessive. So these guys here who are carrying it they look like this. They're carriers. Mom here doesn't have it. She's not a carrier, so she looks like this. And then our boys, they're all gonna look, sorry guys, oops, apologize. You get your X from your mom, so they get the recessive X. So when it says, why does individual in generation 4, individual 7, so all right over here, why is this person colorblind? Because it's a female. So females don't usually express colorblindness unless they have a colorblind father and a carrier mother. And that is exactly what happened here. So her dad is colorblind. So why do they express it? Because dad is colorblind. Oh, that does. My pen doesn't always work. Is colorblind. And mom is a carrier. Why do all the daughters in generation 2 carry the colorblind trait? Well, that's easy. Dad is colorblind. And so what happens, dad, for them to be female, they have to have 2 X's. We get one for mom. Mom was recessive. Well, dad's colorblind. So the only X that dad can give you is dad's colorblind X. I apologize. I have these as dominants instead of recessives. Okay. And so dad has to give on colorblind. So if your dad is colorblind and you're female, you're a carrier. You just are. You have to be. Because that's the only X he can give is a colorblind X. So name 2 in generation 4 that are colorblind males. So we have 1 and 5 are both colorblind males. So 1 and 5 are both colorblind males. And that's how we read a pedigree.